restart our review video for section 4.7. That is chapter 4, section 7. And as always, we always start with the learning target for the day. The learning target for today is to identify similar polygons and find missing measures of similar polygons. So we've got some vocabulary that we have to cover. We need to learn what a polygon is. We need to learn what similar means, corresponding parts, congruent, and scale factors. So let's get those notes down. A polygon is a simple, closed figure in a plane formed by three or more line segments. So it could be a triangle, it could be a rectangle, it could be on, up, and sides from that. Polygon that has the same shape are called similar. Polygons that have the same shape are called similar. And corresponding parts are parts of the similar figures that match. Congruent parts have the same measure. They're equal. And the ratio of the lengths of two corresponding sides of two similar polygons is called the scale factor. The scale factor. Let's try and summarize what we've learned here. If two polygons are similar, then their corresponding angles are congruent, which means equal. So in this case, angle A would be equal to angle X. Angle B would be equal to angle Y. Angle C would be equal to angle Z. The measures of their corresponding sides are proportional. Corresponding sides are proportional. So side AB, that's this side, is proportional to side XY. Right? BC is proportional to YZ. And CA, or AC, is proportional to XZ. And the important thing is that these proportions would be equal in a similar triangle or similar polygon. So let's work with one of these. Determine whether the triangle DEF is similar to triangle HJK. Well, the first thing we need to do is look at it and see if their angles appear to be the same. Well, we can see by our markings that these are right angles, so those are equal. So angle D does equal angle H. That checks out. We can also see that E is equal to J, so angle E is equal to angle J, and angle F is equal to angle K. So far we're doing good. We need to see if the proportionality between the sides, the scale factor is the same. So 4 is to 5, so let's go 4/5. Is that the same as saying 5 to 6.25? And is it the same as saying 3 to 3.75? As I start to evaluate these, I need to see if each of these ratios is the same. A number of different ways to do that. I can check this cross product and see if that comes out to be the same. So 5 times 5 is 25. 4 times 6.25 does come out to be 25. So far I'm on a roll. And I can check these to see if they come out to be the same. So 6.25 times 3, that'd be 18.75. Is that equal to 5 times 3.75? It's 35, 37. 18.75. And those do check out, so those are similar triangles. The proportions are the same. So that is a similar triangle. You do this one and come back and we'll find out if we have the same answer. So just pause the video. first thing I need to do is look at my angles and see if they are equal. Angle B does equal angle I. They're both right angles. According to the symbols, angle A does equal angle T. So I'm okay there. Angle C does equal angle R. So far it's okay. Let's check our ratios of sides. Let's say 3 is to 4.5. And we're questioning whether that is equal to 4 compared to 6. And is that equal to 5 compared to 7.5? I'm going to actually work through these fractions on my calculator here. 3 divided by 4.5 equals 18.28. Sorry, let me check that one again. That doesn't sound right. Is 0.66. Let's check 4 divided by 6 is equal to 0.66. So far we're on a good track here. And let's go 5 divided by 7.5. And that also is equal to 0.66 with a bar. So yes, these triangles are similar. They meet all the requirements to be similar. All right, now let's talk about these drawings here. Given that rectangle LMNO, LMNO is similar to rectangle GHI and J, find the missing part M. Well, since I know that they are similar, I can say that the ratio of side 2 to 3 must be equal to the ratio of 4 to M. Now, in solving this equation, I'm going to do my cross products. I'm going to go 2 times M is 2M is equal to 3 times 4, which is 12. So I've got 2M is equal to 12. I'm going to divide both sides by 2. I've got M is equal to 6. So M equals 6 in this problem. Do this one and come back and check your work against the video. They tell us that triangle rectangle A, B, C, and D is similar to rectangle W, X, Y, and Z. And they're wanting us to find the missing side M. So I can set up a ratio of 3 is to side 7.5. So this side compared to this side is equal to 6 over M. Again, cross multiplying to solve here. I've got 3 times M, so that's 3M is equal to 7.5 times 6. 3M is equal to then 7.5 times 6 is equal to 45. I'm going to solve for M by dividing both sides by 3. And I'm going to get M is equal to 15. Key concept here, two figures with similar, if two figures are similar with a scale factor of AB between the sides, A to B, then the perimeters of the figures have a ratio of A to B also. So here's a problem. A polygon has sides that are 2.5 times as long as a similar polygon. So here we'll just draw a square. It didn't have to be a square. This side is going to be X. Well, then the similar one is going to be 2.5X. The And they're asking about the perimeter. Well, remember, the perimeter is the distance all the way around the outside. And the perimeter here would be all the way around this outside. So the perimeter is going to be equal to 2.5 times the perimeter of the original one, which they told us was 42 inches. So 2.5 times 42 inches will tell us that I want to check that. Be 105. So the perimeter for the new one, the perimeter of the bigger one, is 105. 105 inches. Please do this one, and then come back and check with the video. According to the instructions here, I have a polygon. Let's make it a triangle this time. It doesn't have to be a square. It can certainly be something else. And the perimeter for this one is 77 inches. And the perimeter for the similar triangle is what we're looking for. And the ratio is 3.5 times. The scale factor is 3.5 times. So 3.5 is to 1, as our unknown perimeter is to 17. So I can solve for this one by cross multiplying. Perimeter times 1 is equal to perimeter. And this would be 3.5 times the 17, the original perimeter. I'm going to do that on my calculator. It's 59.5 inches. Is the perimeter of the new one. Thank you.